Okay, so to start with, you're reviewing this. That is exponential form because it has a what in the what? X in the exponent. Very good. And the starting number is like how many you started with would have been 3. I can tell from that number. And then, can you tell if this is growth or decay? Growth. And I'm going to write it a little differently because remember me saying that it's a lot easier if you have a 1 plus or a 1 minus something? That was a 2. So I'm going to say 1 plus 1. It's the same exact answer. It's just written out better. So you won't, by accident, say the growth rate was 200% because it wasn't. What is the growth rate on this one? 100% growth rate. Okay, so that means if I wanted to know what happened after 3 years, if this is our growth per year, what happened after 3 years, where would the 3 go? And the X. And if I did that, can you do this in your head? I bet you can. 1 plus 1 is 2. Why am I doing that first? Because it's in parentheses. 2 to the third, why am I doing that next? Because it's an exponent. What's 2 to the third? 8. And then what's 3 times the 8? 24. It comes out to 24. Do you get y equals 24 is the end? The y is the end number. This is what I started with. This is what happened. And this is the ending result. All right, so what we're going to do is do some M&Ms which have an M on only one side, and you're going to take the M&Ms and you're going to roll them out on a piece of paper. And why a piece of paper? Because you don't want to eat off of this thing. Who knows if it's one on a desktop, you know? But if you have a nice, clean, fresh piece of paper, that probably is clean. I can't even promise that. I mean, if you have your own paper you want to use or whatever, you don't even, first of all, there were groups that didn't eat them, which is totally fine. I mean, it's probably too much sugar in your diet anyways. But I'll leave it up to you. If I were going to eat them, I would just be very careful with them and not let them go on the floor and that kind of stuff. All right. So anyway, I'm going to give out these M&M packets. You're going to each get an M&M packet. And then after you open up your M&Ms, don't begin to eat them. Obviously, we need to do the experiment thingy. All right. So we'll start with 4 M&Ms that are out, and you will purposely put them M side up. All right. Then you will take those 4 M&Ms and you will pick them up and put them in this little cup that I'm going to give you. And then you're going to roll them kind of like dice. But again, don't be too violent with them. They'll just roll off onto the floor and then you can't eat them. So, all right. So anyway, just gently roll them out onto your little surface. And what would you predict would happen if you roll 4 M&Ms out? 50-50. You would think it would probably come up where you had 4 as your starting number. You get how that's kind of like u sub 0? Like as you start the problem, you have 4 up. And if u sub 0 was 4, what would u sub 1 be? Probably, we're doing this first example as growth. And I know this is a little weird because you would say, well, there was 4 up, now there's only 2 up. That's decay. But what we're going to do is add up the total number of m's that have been up. So if after the first trial we got 2 of them, which is likely, right? We got 2 of them out of those 4 to become m's, then I'm not going to say 2, I'm going to say 6. Do you get what I'm saying? You're going to say it went up by 2. Now you take 6 M&Ms and you roll them out. What would you expect would probably happen? You'd have how many M's now? 3 more. We're going to add up a total, and that will be 6 plus the 3. 9 M&Ms have appeared up. We're getting a running total. You know what I'm saying? And take a wild guess what those numbers look like when you graph them. 4, 6, 9, etc. Do you think it might be exponential growth? Spoiler alert. Okay, so then you just keep that running total going until when? Well, until you run out of M&Ms. And if you're in a group of like 4, then you'll have 4 packets of M&Ms that you'll be working with. So it's usually, you know, you can get a fair number of trials of this. All right, so let's do one more. So when you roll the 9, you can't have 4.5 of them come up with M's. It might be 4. I've had some groups where they were rolling like 4 M&Ms, or sorry, yeah, they were rolling 4 M&Ms, and they were expecting to get 2, and they were getting 0. And then they rolled it again, and they got 0 again. And then they were smart enough to go, wait a minute, there's no M's on these M&Ms. There are some of them that I would have been really sad if they'd done it like 9 times, like, it's the perfect roll. No, it was just there was no M's, okay? I really doubt it's because they licked them off. It's just some of them don't have M's on them. So there's some flawed M&Ms. So if you could look at the beginning, it would be smart, because there are some of your M&Ms that will never come up an M because they don't have an M on them. Okay, so make sure that your M&Ms, any flawed ones, the cool thing is if you find a flawed one in your bag, you just get to eat it right away because it can't be used in an experiment. Okay, so that's really a lucky M&M actually. All right, so after this happened, would you agree it's probably going to be 4 or it might be 5? Because that's 4.5 is what it should be, so it's probably going to be 4, it's going to be 5. Let's say it was 4, and then your U sub 3 number will be 9 plus 4 is 13. All right, but nobody's going to actually have these numbers. Nobody has anyway so far had it come out the way it's supposed to come out. If you've ever flipped a coin, you know what I'm talking about. It doesn't just go exactly. You flip it 10 times, it's not 5 heads and 5 tails. If it is, it's actually incredibly lucky, which is weird because that's what it should do, but yet you're lucky to have it happen. All right, so anyway, that one is called exponential what? Growth. All right, so what if we wanted to do decay? You'll have about, let's say, 36 M&Ms total. It's going to be more than that, but I'm just making a number that's easy to divide by a lot of things. 36 goes into a lot of stuff. And I start with 36 M&Ms, and I just roll them out. This is the part where you start to eat them. So you have your 36 M&Ms, you roll them out, and let's say, what would you expect to happen in U sub 0? Well, U sub 0 is 36, and then U sub 1 is after I rolled them once, 18 of them probably appear up. And I'm going to write this down, just so hopefully you can remember this. M&Ms that are up go back in the cup. Snappy, isn't it? M&Ms that are up go back in the cup. What do you think you do with the other ones? You eat them, you share them equally amongst your little group. All right, so ideally for you guys, you want to find some people, it's sometimes girls, who are saying, I'm not going to eat these. And so you really want to find like 3 or 4 people who don't want to eat the M&Ms. That way you get all of them. So anyway, I'm telling you, some people are going to probably say, oh, I don't want to eat them. So find those people to be in your group, because then you can eat more. That's what I would be thinking strategy-wise. All right. So if at the end, if you have been one of my, you're already losing your chance at this. If you've been one of my cooperative students that is not like hanging from the walls and ceiling because of the M&M effects, I do have some peanut ones that if you want them, I could give you a bag of peanut ones to consume later. I just don't want them consumed in here because I have people with peanut allergies. But if you want to take it home with you and consume a bag separately at the end of peanut M&Ms, I have some of those to share with you if you'd like. Okay? All right. So do you get? You're going to be displaying both exponential growth and what's the other one called? Decay. All right. If you roll out your 18 M&Ms and 9 of them are M's, what do you do with the M ones? M&Ms that are up go back in the cup. All right, good. Now, one thing to warn you about: when you get to the end, you're going to have a temptation to get to 0, but don't. Why? Because if you got 4 and then 2 and then 1 and then you go to 0, your calculator freaks when you put in a 0 in the data set. It says error domain and it won't let you get an answer. Okay, so don't put a 0 into your list at the end. When you get down to 1, that'll be your last one, and then you can just eat it. Okay? All right. So, next thing, I got to show you how to use your calculator. So grab your graphing calculator. There's a thing called an exponential regression equation, which can do the work for us. It's kind of nice. Grab your graphing calc. Now I'd like you to put in these numbers and I'll show you where, but first of all, hit stat. Just start there. By hitting the stat button, I'll leave it red for a minute while I hand out a few calculators to people that have forgotten theirs. So, we've got the stat button pressed, okay? Now, what is the three tabs across the top? Edit, calc, and tests. We aren't going to ever use tests, but we're going to use edit and calc today. To start with, you are editing. You're editing what? You're editing your list. Hit enter, and you have edit. You need to borrow one. Just there you go. Make it fast. And once you're in your list, please type in, please stop turning around and talking to people. Put in 0, 1, and 2 on this list. And you may recall I said you shouldn't use 0. Actually, your L2 list is the one that can't have a 0 in it. 0 is actually a good thing. U sub 0 is your first trial. That's what you started with. Okay, so 0, 1, and 2. So this is that kind where you had 4 M&Ms. You start with 4 of them face up. And then you got 2 more to come up. So now your total is up to, oh wait, actually, I'm going to make this a 6 because that would be much more realistic. It would have to have all 4 of them have come up. And then I have 6 M&Ms. I roll them. I'm likely to get 3 of them to come up. So 6 plus 3 would be 9. This would be like perfect data. It's not likely to be perfect. And that's okay. In fact, I'm going to tweak it just a little bit to show you what happens when it's not perfect. So we're going to make that 9 into, oh, we got 1 extra M&M that came up like more than it should have. So I'm going to say that's 10. So everybody make it 4, 6, and 10. Now the calculator is going to, first of all, judge, is this exponential data or not? And if it can reject your data if it's not even close. Now this data is close. The only number that was off was that 9, that 10 should have been really a 9. But this is close enough that the calculator say, fine, that's exponential, and let me show you how you get an exponential equation now. There's a temptation to want to like save this. You don't have to. It'll save itself automatically. It's sort of like a Google Doc. You can go away from it. It'll be there when you come back. Hit stat again. And this time, take a wild guess where I'm going to go next. Calc for calculate. And I'm going to calculate, and I wish it was on the list here, but it's the first one that's off the list. It's number 10. It's past linreg and past lnreg, and these are all regressions, they're called. You want expreg. That stands for exponential regression. The calculator is going to make an equation for you that is exponential. You hit enter. Now, the newer systems, which is going to be most of the class, has the screen that I have. If you have the older system, nothing came up when you hit that. But you now have to say after, I'm sorry, that's not nothing. If you have the old system, it says this, expreg on your screen. And you have to, if you have the older system, type in L1, comma L2. L1 is right here. Choose a different color right there above the number 1. That's where L1 is. And above the number 2 is where L2 is. And you have to have a comma in between them. So what did I say to type in? L1, comma L2. Now that's the people that have the older operating system. You have right there, you type in L1, comma L2, and you hit enter. If you have the newer operating system, it is nicer because they default to L1 and L2 for you. And all you have to do is arrow down and hit calculate and hit enter. And this is the regression equation. Now, if you think about it, shouldn't it have started with the 4? But it didn't, because it's trying to make its equation fit the data as best it can. Let me show you what I mean. Do you get, if you have a bunch of points like this, that you kind of can see that the line should sort of go through the middle of them like that? Do you get, since there's variability in the real world, you're not going to get a perfect 4.0 for a start. It has to tweak it a little bit. You know how the starting number is this number? It has to tweak it a little bit to make its equation fit. It's sort of like saying, if I give it data for flipping a coin, you would expect it to come up 50-50, right? But in the real world, it wouldn't. And so it has to take the data it has and say, you know what, this is kind of the average of the data. It's actually doing this complicated process where it's figuring out how far away each point is from the line, and it's minimizing that distance so that it is as close to all of the dots as it can possibly be. All right. So again, if we wanted this to have come out perfect, we would have had to give it perfect data. And I want to go back and do that now and show you the difference. Okay, wait a minute, one more thing. That b, that's the sorry, not the exponent. It's the b part of your regression equation, which is right here. And it should have been 4, should have been times 2 to the x. Do you get both those numbers were off a little bit from 4 and 2, but they were close? Does that make sense to you? Why should it be doubling? Because we were doing exponential growth, which you'd think would double each time. And if it's off a little bit, it's because our data wasn't perfect. Remember how we can make our data perfect? Go back to L1 and L2. This is in the list. Edit your list under Stat, Edit, and we'll go tweak that now to a 9 and say, okay, that's perfect data. Let's see what it would look like now. Now you go to Stat, Calculate, Exponential Reg, that one. And I got to enter down until it says calculate. And look at that. It starts with A is 4 and B is 1.5. Wait a minute. If I give it perfect data, it seems like it wants to have a 1.5 for this number here. I was wrong because I was doing this part wrong again. Do you get we'd want 50% growth? 1.5 would actually be 50% growth, not 100% growth. Do you get that when you're making something grow, if it's going to grow 100% each time, you'd have had to roll all of them M's, and your 4 would have turned into 8. And then you'd have 8 M&Ms, and you'd roll them. And if they all turned out to be M's, then it would have turned into 16. That's what doubling would have done. So again, this number here is your growth rate. You wouldn't expect all of them to be M's every time. If you did, then this would have been a 2. All right. So all I'm trying to say is I get this question all the time. People are like, but Mr. Server, I know it started with 4. But my calculator says it started with 3.9. It's your calculator is trying to get as close as it can. And no, you shouldn't overrule your calculator. It's got the closest graph it could, and its equation is better than any equation you could have made up. And you don't want to overrule your calculator. You want to just write down what it says that the right equation is. All right, so that's what you're doing for the little lab thing today. You're going to do it in class. You're going to finish it in class, and you're going to hand it in class. And then your only homework for tonight is to take the same worksheet I had you start yesterday. Remember, you're supposed to do the evens. Some of you probably forgot and didn't do anything. Well, you got the weekend to finish it all then. So all I'm having to do is take the assignment we did yesterday where it was evens and finish it to do all on that worksheet. Okay? All right. And I'm going to just pause this just in case you have more good questions or something at the end, but this might be the end of the video. We'll see.